Okay, I got that running. I want to do, Juan was just saying that he couldn't figure out how to get his, I think it was his blue pill, couldn't get it to talk out the USB port. And I was going to show, so if my screen is showing up, that's my Arduino screen. And under tools, so of course now, no, with nothing plugged in, it's not going to do anything. Let me plug in a board here. And say tools. Okay, now everything's showing up. Can you see my screen at this point?
Yes.
And I don't know how to make that any bigger.
No, but it's okay.
So right now on the 407 board, I said select the generic STM32F4 series. So if you come over here and scroll down, you can see that there's a block of them. So I either use the 103, or so right here, I either use the 32F4 series. So it's generic F4 series, or I use the F1 series for the blue pill board. So then when it comes up, it says what kind of board do you have, and I don't know what I should put in there. It defaults to this. I think it says black 407 something, and I came down here and picked this one that says FK407M1, and then it says STM32F407 VET. So since this has a VET chip, that's what I picked. And I don't know if it matters what you put in there for a board. And then here's the two things to get to talk over the serial. One of them says, do you want to enable the serial or not? And the next one says USB support if available. Now, it turns out when you change any of these parameters, that always switches back to none. So you got to make sure that after you've changed anything, you go check that and make sure it's still on.
Yes.
And mine
that was the problem that I got, and I was able to solve it 20 minutes ago, and that was what I was trying to. I'm not sure which is the difference between these. Can you explain me?
Between what, those different modes? Yes,
it's something valuable, or I leave it like that? Because as I noticed that I don't know, accidentally I touch it because I wasn't in the in trying to touch something of that. So I'm not sure why change it in my configuration in the setup of my board. But that was the problem, that I wasn't able to get the USB working as a debugger.
Well, the reason I picked this one that says generic serial supersede USART is because when I went through that tutorial for the 103, the blue pill board, he said set it to that. So I did. And then that does appear to work. So that's just the one that I use. And if you say no serial, then it's not going to talk out that port. And the HID makes it look like a mouse or a keyboard. And that's not what I wanted. I wanted to get serial messages out. You want to pick this one that says generic serial supersede USART. So make sure you have that one picked. Now, as far as the processor speed, for the blue pill, they say set it to low or full speed for the cheap ones that you buy from China. And I don't know what the other ones do. I think if you go to high speed, it's something about the block size of the memory. So they program differently or something. But anyway, if you're doing a blue pill, I always leave it on low and full speed. And now what I picked for the 407, that I left it set at that because it defaulted to that, and it appears to work. So I haven't made any changes on that. So that's when I go as the low and full speed. And the rest of the stuff, I don't really know exactly what it's doing, and I haven't had to change anything. So you come down to the upload mode, and if you're using the ST link, you pick the one that says STM32 Cube Programmer SWD. SWD is single wire debug is what that stands for. And in fact, if you look at the board right in, I think right here on the board, which you can't see it right there, but in between those connectors, it says SWD on the silk screen. Just if you're wondering what that's for. So anyway, what I did on mine, I just have I've just got, right now I have 4 wires hooked up because if I want to program it, well, I just noticed something else here. So anyway,
I got 4 wires.
I've got 4 wires hooked up, which means if the STM the ST link is plugged in and the USB is plugged in. I'm applying power from two different places. So far, it hasn't seemed to blow anything up. So that's what I've been doing because it's easier. Or you could just unplug the USB and it was odd because I pulled up this menu and I didn't have any thing talking about the board. And so I plugged in the USB cable and I should have plugged in the ST link cable instead. So, but anyway, I don't think these values will change. So since I have the USB cable plugged in, it says I have COM8 hooked up. So let me unplug that and we'll do an experiment here and see what happens. So I'll plug in the ST link. Let me close this window and then say tools.
The only thing that I noticed is that if you got the two ones plugged, the SWD gets hot, very hot. So maybe you,
What
if you
gets
are
hot?
going- this
What-
one.
Huh.
If you got the USB, I got it like this. I got it
Okay.
like this, and when I got the both of them plugged, trying to get the USB working, I got it get real hot.
Okay, then I guess the answer is don't do that then. So don't plug it. If you're going to do that, don't plug them both in at the same time, I guess is the answer to that. So I just plugged my the ST link back in and all the values are still the same. Nothing changed when I did that. Oh. So here again, it's switched back. So that's why you got to it'd be best to check that every time before you program it. Yeah, and after a while, you'll learn if that's going to work or not. So we'll say set that back to supersede, and that should now. At this point, it would program. It seems to take forever for the thing to compile, and I don't know why. I started up, and it takes like 60 seconds or something, and you just got to sit there and wait for it. And basically,
yes, that's something about Windows. In Linux, it does it in a completely different speed when it compiles.
Okay, because I am running under Windows right now, and I haven't tried it under Linux. And I thought maybe that would be the case, or it's just that this Windows computer I have, it's a little one that might be slow. So anyway, that's the way I set it up, and I won't go ahead and program it because it, as I say, it'll sit here for a long time, and then just it pops up. Well, here, let's do it just because. So I'll pull this up. And I just have the ST link plugged in and the USB cable is not plugged in right now. And this is the 407 board. Now I don't do anything with the built-in bootloader. It's just hooked up and will work. So if I say, I should start this while I'm talking here. So I'll say upload and compiling sketch. So you can see over here on the side, the little scroll bar is sitting there and it'll come over and all of a sudden I think it'll fill up the whole thing. There, just disappeared completely. Oh, there it goes again. But then here it'll put up a bunch of messages as it programs. So it's just painstakingly slow for whatever reason, but Juan says it works under Linux, so maybe that'd be the way to do it. Switch over to Linux.
Yes, I this morning I was switching between Linux and Windows, trying to find out if the problem that I got was something about the configuration in the Linux Arduino IDE. And that's why I noticed that difference. And I think that that was what I noticed, how I noticed that I got the problem in the configuration, in the setup of the serial port in the USB serial port.
And you can see the LED is blinking on the board right now.
Okay.
And I guess you probably, it's a little tiny window. You probably can't see that since I'm sharing the screen.
No, I can see the LED blinking.
But it should be catching up here pretty quick. The screen is still thinking it's compiling for whatever reason.
That's the only the blinking or the blinking for ROS?
Blinking for what?
Yes, because you got a blink example for ROS and a blink example for Arduino.
I'm just doing the Arduino stuff. So it's just
Okay.
the standard Arduino program, and I changed the LED name from whatever they had. I changed it to PA1, I think it's called, to get the LED to blink. Oh, there we go. It's finally going to do something. And bang, it's done already. And the LED is flashing. I think it's flashing slower now. And let's go back and see what it said. Up here it says it finally finished compiling. It's giving me information on my ST-Link module under reset, hardware reset. I've never really analyzed this too hard before, but if we look through this, and it says memory programming, and it took like just a fraction of a second to actually program the board, which is, so it's a shame that Windows or the compiling takes so long to run. And it says,
I'm not sure why is the reason, because I never had something similar in Windows, because if you try to compile other type of files like Arduino Uno and others, you don't have, maybe it's something about the STM32Dino library.
and it could be if you specifically, since it's slower in Windows as opposed to Linux, just search, go on Google and say, why is it slow? It could be, oh, you got to change the setting or get a different version of something that might be able to fix it. So I'm just looking at the messages that came up here. I'm down to the bottom of them here. So it said it went through and it said it erased the memory. File download complete. It took 1.3 seconds to download it. And it doesn't say that the download actually programmed, but I assume that's what they're meaning. They just took just a little over 1 second to program that thing into it, even though it took like a minute or two to compile the thing. So down here, it says it's running and everybody's happy. So now at this point, if I close back down, unplug the ST-Link. Actually, on mine, at least on the 407, I haven't noticed that anything gets hot. So I probably could leave it plugged in, but I don't have enough USB ports right now. So I'll plug that in. My computer beeps and says, down here it says COM8, which doesn't always match, but we'll just try it and see. And so there's my message that it's putting out. This is what was programmed in. and I simply put this on so I know what I programmed it with. So it's the ST-Link module, 500 millisecond blink rate. This is my bad board. I've got of the two boards, one will not go into DFU programming mode, and the memory size is invalid on the chip. But the other one seems to work. I can program it with DFU if I want to. And here I say no boot 0, which means I didn't put it in boot mode to do this. And it's with the USB. And if I didn't have it with USB, you wouldn't be able to see the message. So that does work. So it's blinking and putting out messages from the Arduino IDE. And it turns out with the ST-Link module, I can program from any of those programs that we listed, either the Arduino or the STM Cube IDE or the STM programmer. Any of those will talk to the ST-Link, and I don't have to do anything with boot jumpers or anything else. You just, in fact, with the program running, with the LED flashing, I can just go to my Arduino and say download. And when it gets to that point, it just stops the board, downloads it, starts the board up again. So if you had this in circuit, buried in down inside your computer, theoretically, you could talk to it and everybody would be happy. Except, but I haven't tried on the what's this called, the blue pill board, which here, let me stop sharing. I think that's all we needed to see there for the moment. So
Well, I can show it the blue pill from the to the blue pill board, because that was what I was able to do it. So if you want, I can share my.
I wanted to make another couple more comments. As I was saying, it looks like you could put the 407 board, bury it down inside of the thing, and I think I didn't notice any problems having the ST-Link and the USB connected at the same time. One way around that would be to disconnect the 3.3 volt pin from the ST-Link to your 407 board and just let it power it over the USB. So that way it gets all its power from the USB and everything should be happy at that point. Now, so if that gets to be a problem, you could do that. Now on the 103, if I have see the ST link hooked up, and then I hook up the USB at the same time. You're saying if that's a problem, you could probably do the same thing on that. Just disconnect the 3.3 volt wire between the ST link and the board, and then maybe everybody would be happy at that point. So what I was thinking is, if you can get that to work, then you can just leave it buried down inside of your box, and whatever your ST link is plugged into, as long as that can talk, because that brings up the other point. Somewhere it says you're supposed to be able to use this with platform IO, and Al found one that was there's a Arduino has a command line programmer version. So, you know, if say if this is plugged, ST link is plugged into your Raspberry Pi, you know, theoretically from a command line there, you can do something that says download the board, and you don't have to monkey around with the board. You don't have to do anything, boot jumpers or anything. It should just go ahead and reprogram the board and come back up and run. So I think that would solve most of the problems there. You know, regardless of which of the two boards you're using, I think that probably would work. And then likewise, if I were to take my F4 Discovery board, and you know, it's just got the USB cable, it should work the same way. It's just that I'd have to get the right parameters set in either an Arduino or Platform IO or whatever I'm using to talk to it. Make sure I tell it the right kind of board, and tell it it's an ST link programmer and so forth. And I think all of that would work. And the other point is you can put a jumper on the 407 board, because there's a difference between the F4 and the F1 processors. The F1 did not have this built-in DFU bootloader, so they put it's got the two jumpers on the board, and you can move the jumper pins around and make it do things if you want to load it over serial or something else. But just hook it up, plug it in ST link. You don't have to do anything with those jumpers, so that's good. So you know, you don't have to rip your whole robot apart to move jumpers around to program it. So that's good. What was the other point I was making? Oh, but so the F4 processor, being a newer processor, they have that bootloader program built into it. So if you put the jumper on, and here on this one, it has. As I was doing this, I'm trying to remember how I have my recording set up. But anyway, at this end, there's two pins coming out of the board right here, and this will be out of focus, I suppose. And I just put one of those shorting jumpers across the two. So when I plug this one in, it comes up in bootload. So either I can talk to it with a USB port in DFU mode, and it turns out Arduino will talk to that also. So if you just under the thing where it says what kind of programming do you want, you say it's like STM32 programmer, and it says DFU instead of SWD. Or if you wanted to talk to the, I don't know, somewhere along here is the UART pins. So I think you can either use the DFU or the UART pins if you've got that boot jumper on. But that means then you have to get in and hook up that boot jumper. I suppose you could run that out to the side of your box and put a push button. So you'd have to bring out the reset and the boot. So you'd have to play around with those push buttons to make that work. So it looks like the ST link just solves all that problems. You know, if you're willing to leave that ST link in your system all the time, I think you just plug that in and everything will be happy and should function at that point. So that's I guess that's all I wanted to say on any of that.
Well, make me host so I can share mine.
Let's see, one more. Okay, it should be.
Okay, so as Chef explained, he has been helping me the last 2 weeks in trying to find out which was the problem that I was having with the blue pill and the others STM32 board, trying to achieve the communication between the I will plug and show because the board got two ways to communicate. From here with the I don't know how the USB dongle specific for eSteam, and you can use this micro USB to get the serial communication out of the board. I wasn't able I was able to push the data to the board, but I wasn't able to read it when I tried to get a serial value from a sensor. I was mainly the first days I was trying to only do a chat, a serial writer, but then I was trying to use a T1 accelerometer, the one that got free access, because I want to get more EMU in my robot and get more confident about ROS and Arduino. Well, the case was that as I couldn't use it, I wasn't able to get that confidence. While I was trying to do this, I switched from Linux to Windows and from Windows to Linux, trying to see if it was something about the configuration of the driver of the USB in the Linux, and I found out that I got difference in the configurations between the Linux and the Windows Arduino IDE. When I got a hint about what was the problem, I found out that I'm not sure. Maybe it was the same that happened when Chef recently changed it, one of the parameters in the setup. It goes down to 0 again, but I wasn't getting the CDC generic serial supersede use word. So I didn't get the communication. Magically, after that, I get the configuration and I was able to get the Arduino working and get the data. I will try to show it. I'm not sure if it's going to work, but I will try to show the. Okay, and there I'm getting the information from the board. As I move the sensor, you will see the axis changing in the the thing that I will try to achieve now is well, I will unplug that's why it freezes. I will achieve to move this to the simulation but I wasn't able to do it. I don't know why. I'm not sure. Sorry. I will try to go to the. I want to give the tractor in Airbus the EMU with from the sensor and try to move the tractor there with the EMU. So I will have to transform that data in a topic, so I can use it with a node in the ROS system. I was able to push the data, but not constantly. So I'm not sure. Surely I got something in the configuration again that I will try to solve the next weeks.
I did notice that the links you posted last week were you had a link for the blue pill board and a link for the 407 board to do ROS serial. And I noticed both of those were from the Cube IDE as opposed to Arduino. And I did some searching and it turns out I think I found there are versions you can get ROS serial that'll work under the STM32 Arduino code, so that, if, because that becomes a question, how do people want to develop this stuff? If you were to go and buy the STM boards, would you want to use the Arduino interface or use the ST micro interface? And the other thing I thought was, there are various things you might want to run. And since that project you started with had that free RTOS in there, and when I looked that up, it says, yes, that runs under STM32 Cube IDE, but I went and searched for free RTOS and STM32 Arduino, and sure enough, there is something you can load right in. So if you wanted to put the free RTOS on this board and still stay with Arduino, it looks like you could do that. And
Okay.
since I always have to have the quadrature encoders, I searched for that and I found 2 or 3 projects that may indeed work. And in fact, there was a PDF published by the Dallas Public Robotics Group, and they were talking, I think it was the slides from a presentation they gave, and they were talking about how to get this stuff to run on the STM32 Arduino code. So he went through some steps and said, pull up the Cube MX, configure all your pins and your peripherals, and generate the code. And then he said, okay, this is the code you'd want to cut and paste into your Arduino code. And I don't know if I can find, I'll track that down. I'll post that link. And
Okay.
as I say, I think it was slides from a presentation. If I could find the original presentation on YouTube, then he would probably explain it as he goes along. But that's a good example of how you use that Cube MX. It's a tool that lets you configure the chip. So he configures it that way and then says, okay, take the code that it generates and paste it back into your Arduino in order to make this stuff work. So it's good to see the steps on how to do that and taking advantage of that.
Okay. Okay.
So it comes back to the question, do people want to use Arduino IDE to do all their programming, or do they want to figure out this big STM32 development system? So there's 2 different ways you can go there, and I haven't. If I'm going to do it, I'm still using the big development system because that's what I started with, and I didn't want to try to figure out the Arduino stuff up front. I don't even know if it existed at that point when I started, so that's why I'm using the big system to do my stuff. But I could switch over to the Arduino IDE. It looks like.
I'm not sure because I never use it other thing than an Arduino. I use VS Code and Platformio that is very similar to Arduino, but it's STM32 IDE. It's like overwhelming for me. But as everybody is telling me that all the things that are overwhelming are there to help me, I always keep giving it a chance to try to understand it. But the main thing is that I didn't have problems with the STM32 IDE. The problems that I got was with the Arduino IDE and the configuration of the Arduino IDE, and I was having troubles with that. It was getting me frustrated because you can see all that examples, and you cannot and you are not able to port it to your board and to your system. I feel so stupid about that, but I hope that the next weeks I will be able to push more. My main objective now is try to get at least one publisher of a sensor, but a quality publisher. Besides, I was able to do it with the temperature sensor, but the temperature sensor won't help me to achieve any goal of navigation. I want to use sensors that will achieve me goals of navigation, like the accelerometers and the encoders and that kind of things. So I will try to focus on my work there, and first of all, I will try to when I achieve the moment that I can publish the ROS topic chapter, at least I will try to leave it in a repository so everyone can go from there and get the installation. One of the problems is that I touch a lot of things trying to achieve this, and I think that I got a real mess. If you can look here, this is the board. I don't know how to say the board folder in my Arduino IDE. I got 1, 2, 3, 4, 5 files for configurations of the ESTM32 boards. So I touch a lot, and sometimes I have to reset the IDE and start from zero to be able to get to show a good documentation, because when you keep on trying things, sometimes you the IDE gets some kind of blurry, because you got a lot of items that doesn't need to be there. So you got to go simple. You got to go to the basics again, reset and restart it, and try to do it from there. And I will try to go 2 steps backwards to get the good documentation about this as a process, because they are a good documentation and about this, but they are all separated.
And it's always good when you publish something, say, here's what I did. If you put a list of links to other people's, anything that you use to help you along, put that link like as a comment right into your code. Or if you're putting comments on, say, if you're doing it on GitHub, down under the README file, say, these are links that will tell you how to program the Arduino, how to get the sensor to work and all this kind of stuff. So it's good to just put all that stuff together. And if you point to people's YouTube videos where they're taking you through step by step explaining it, it's always good to put all that stuff together and say, this will help you out if you're trying to understand this, as opposed to looking to open source code that has no documentation.
Yes, and getting, for example, in GitHub, I don't know, I'm not sure how to do it right, but one thing that is important, as in YouTube, is to get the right tags when you are creating a document. And so when they search because GitHub is very a vast repository, so you got to put the right tag in your repository, so to be easy to find it.
Another thing I noticed, if you search on YouTube and say, I want to program a blue pill to do this, blink something, and then the video will start up and says, okay, here's my repository where you can get the code for this. So you go look at the repository, and they never say, oh, by the way, there's a YouTube video that goes along with this. So if you're just looking at the repository, you don't know that this other thing exists. But if you watch the video, he tells you how to get back to the repository. So again, that's a handy thing. If you post something on GitHub, under your description at the bottom, under that README file, very first thing, say there's also a YouTube video that goes with this. So that's another thing that I've been noticing, people don't do that. And so you find this GitHub, and it could be there is an explanation of all this that he's gone through and told you how to do that. But I usually don't see that. People just forget or don't think about putting it in.
Maybe one of the other problems is that mainly when you search for STM32 USB, you will find that a lot of video and articles trying you to avoid buying the programmer. So you can do this, you can do that, you can use this pin, but there are not good examples. You buy the programmer, it's $10 or less. The ESTB2, it's much easier to work with the programmer. And you get a lot of I don't know how to say it, but trash about how to use it in another way or program it in another way, when it's much easier the other way, the easy with the programmer, more straightforward.
And another very important point is, if you have that ST-Link programmer module and you're running the STM32 IDE, you can also directly go into debugging, and you can single step and you can breakpoint and look at all the variables. And I just ran across something saying that the program or platform IO will also let you do debugging, but I think they kept talking about the ESP32. So I'm not sure that it's going to work on the STM parts, but maybe there's another way to do that. So that's another reason to have that ST-Link module, because you do have the option. You can do debugging on your board if you have that. And as you say, it's only a $10 module, so I think that's a very good investment if you're using this kind of board.
Shortage of will see you because there are not much options, and I don't know in the USA, but here we don't have much options. I never use the black pill that comes with the USB C, and I'm not sure if that's some kind of difference, but surely it's a good buy to do it.
As far as the USB-C, I don't think it matters whether it's USB-C or mini or micro USB. I don't think it has anything to do with it. But the black pill board has one of the F4 processors. You can either get a F401 or an F411. And the biggest difference between the 407, the big 407 board like this, or a black pill is this size, it's just that you get half as many IO pins coming off the thing is the main difference between those. Actually, I think this big board runs at a much higher clock rate. It'll run up to some ridiculous amount, like 196 megahertz. And then I think a black pill goes up to 100 megahertz. And then the blue pill, the little blue one, I think they say they'll run either 70, I think they run at 72 megahertz. And
yes,
most of that is faster than what you need for anything that we're doing, but that's just interesting. That's something to keep track of. So. Okay. Back to your availability problem, you say you cannot buy any of the teensy boards where you live. You can only get these.
No. You can find them, but it's not something that is fluid. You will not find it always. You will find it sometimes, but you will always find the blue pill boards, the STM32 407 boards, like the one that you got. The other boards are missing. When you try to go to the dealers that you have, you don't get good provision. The main ones are the black one that you got, the ESP32 with the Wi-Fi, and some of the Arduino boards. But when you are trying to, because one of the main things about the STM32 is that it's something more than the Arduino, and you get a lot of options there. It's like we don't have another thing that it's the only thing that we got that it's a little more than Arduino available.
And for anybody watching this video, what took Juan down this path is he didn't have the availability to all the things we can buy in the United States. So he found this ST Micro. Actually, the project that he was copying from used one of these F4 discovery boards. And this particular one, they don't even make this one anymore. So that makes it harder to find, although there are people like Chinese knockoffs that you can probably buy something that's real close to that. So that's why he's using the ST Micro boards, because that was he could get that easily.
I'm trying to, well, when you do the search, you will get other boards, the F7, but you don't get the discovery. No. And if you go with the ESP32, These are the things that will get available now. Here.
Is this Amazon that you're looking at, or is it a different company that you're looking at?
It's a company in Argentina that is called Mercado Libre. It's very popular in Latam, in Brazil, and in Argentina, and in Mexico. But it's always well, I don't know how to stop. But I don't know why we get this problem with the discovery board. When you go to the specific dealers, you are in a similar situation. You will get something similar, but not the same board. And that's why the road that I asked for help was the migration between boards in ESTEAM M32. That's the main thing, because there are a lot of boards, and sometimes the software that is built for one board is not fully compatible with another board. It's not like the same in Arduino. That's the main problem of using these boards, because you can not so easy migrate between one board to another.
One other thing I wanted to mention, if you go down the path of using Arduino to program these boards, I'm not sure all of the support is there. So for instance, this chip has, I don't know, 3 to 6 UARTs on the board. And I'm not sure if you go to the Arduino code, if you can directly access all of the UARTs that are on there, or it might have more than one I2C interface. And again, they may just supply the default, the first instance of, say, a UART or an SPI or an I2C. And I don't know if you can get access to the rest of them. So that's another thing you may run into if you're trying to, decide to do everything in Arduino. It could be that it's not, it hasn't caught up with all the other Arduino products. And it could be you can't access all the peripherals on the board. So that's just something else to think about.
Okay. Now, maybe the main problem that I was facing is that I wasn't able to publish through the USB in the ROS core. As I push a firmware to one of the boards, and then I replug it to the USB. The USB is not reading or not getting fully compatible data to the ROS core. That's a problem that I'm not getting maybe with an Arduino Uno, that I flash a chatter or maybe the same script that I'm using for the accelerometer, and I don't get the data published as a topic.
So you're connecting with a USB cable between that and your Raspberry Pi. I think at one point you said that project you started with, they were using the UART pins instead of the USB.
No. You can. I was able to do this with a plugin, the Arduino Uno to the Raspberry Pi through the root serial. I was able to do it through the simulation of the Docker file. So to push it a topic to the simulation, but always with the Arduino Uno. I wasn't able to do it with the Blue Pill or the ESTM32 board, and that's important because in every case of a scenario, it's very important to try to push the data of the sensors to the simulations.
What I would do in that case take your new board and plug into your Linux and look at all the parameters, do it like the D message and see if it says, I found this COM port, show up, and it tells you what the name of it is and what type it is, because all that stuff's got to be right before, before ROS will talk to it. It has to be, a valid port available out there. So look through those kind of things. So look at the, do your ls/dev TTY asterisk and see, does it show up there as either an ACM port or a USB port or something else? And then the D message will give you information. So you plug the thing in and say D message, and it'll say, oh, I just saw a new high-speed device was plugged in, and it looks like it's this kind of device, and I'm going to give it this. I'm going to call it an ACM 0 or call it a COM, whatever. And so you can look at that and see if Linux understands, because first of all, Linux has to understand that is a USB COM port that you plugged in. So before you even fire up ROS, that's got to be right. And if it looks like it's coming up correctly, then you can use on these should be the ACM type ports. So you can just say cat space /dev/TTY, whatever the port is, and it should just dump the information on the screen directly. And if not, then you can pull up a terminal program. You'll get a serial terminal program and say connect to that port. Yes, something like that. And if it's putting out messages, you should be able to see it that way. And that's all before you go into ROS.
Yes, I think that's my next step, because I think that's the problem is something about the configuration in ROS, but I will try to test if I'm able to read the serial message through the Minicom port, because that should be much easier than trying to do anything else.
Yeah, those are just good debugging steps to find out, go step by step. And if you get to the point where you can see messages on the Linux computer coming from your board, then you can go to the ROS stuff and say fire up ROS serial and make sure that's talking to the right port, and then see if it's publishing to a topic at that point. So that, just do it step by step until you get all that. And if you get a topic publishing, then you can start up the whole big ROS package and try to get it to do something in your simulated vehicle.
Yes. Chef, I will have to leave. Thank you again for your time and for your support with my words that are bad too, like yours. Bad board.
Okay, I just want to, for clerical purposes, we had no chat, and I'm gonna stop the recording now so I don't lose it. So I'll stop that, and then